Okay, now in the next assignment, you got 4 problems to do at the end. I'm going to go over these front and back, and then you have to do these 4. Now, on the last packet, you were doing your rainbows. Now you're going opposite. You take the product and get back to the 2 parentheses. Now, you'll notice how here we've got x to the second, but the x to the first has been deleted. Okay, so we have to come back to the 2 parentheses, and also the GCFs are all 1s on these. Okay, you don't have to worry about having a GCF, it's 1. Now as we move forward this, we'll check these for GCFs as well, but for right now, they're just 1s. So we're going to learn a new type of factoring with 2 terms. Okay, again, you got 1, 2. GCF's 1, so I don't worry about that. Now, this technique here is known as finding the difference of perfect squares. Difference of perfect squares. Difference of perfect squares. It's known as the DOPS method. Okay? Difference of perfect squares. DOPS. Difference of perfect squares. Now, to check for a difference of perfect squares, you see the x to the first has been deleted. So what I need to come up with is a plus and a minus of the same thing. Okay, this has to be the same as this. This has to be the same as this. One's plus, one's minus. And here's how I do this. My first question: do you have x to the second power? Yes, you do. If you do, then you put x and x right before the operation signs. Okay? Now, is our second number negative? Because on that last assignment, you notice that this number here, the second number always ended up as a negative. You check this number if it's negative. Yeah, it is. If it has a minus, it's negative. So yes, it's negative. Okay? So I'm going to circle that sign. That should be a negative. If it's a plus, you can't use this method. Okay, now are each of your numbers perfect squares? Well, what's a perfect square? Flip this over to the back side. Circle these numbers here, and these are perfect squares. Now, they're all perfect squares because there's a number times itself that gives you that product. So 1's a perfect square because 1 times itself is 1. 4's a perfect square because 2 times itself is 4. 9's a perfect square because 3 times itself is 9. 16's a perfect square because 4 times itself is 16. Okay? And it goes down the line here with this. Now, you could keep going. This is as much as we'll need. So are these numbers perfect squares? Yes, they are, okay, because 1 is on this little list. 1, it's 1 times 1. So then what I do is put a 1 and a 1. Now 49, is that on this list? Yeah, it is. 7, 7. So we put 7, 7. So this is equal to 1x plus 7 times 1x minus 7. Not a lot of work involved. One thing I would recommend, once you get the x's down, if it's the second power, I would put that this is 7 times 7 and this is 1 times 1. Okay? Okay, my next one, 36x to the second power minus 49. You see the x to the second's there, but the x to the first is deleted. Okay. So we see if we have a difference of perfect squares. So remember, do you have x to the second? Yes. So if you do, you're going to put x and x in front of the plus and minus down here in your factors. Is our second number negative? Well, here's my second number. It's negative. Okay. Are each of your numbers perfect squares? Well, let's see. 36, that's on the list, okay? That's 6 times 6. So I'm going to put 6 times 6, and then I put the 6 in front of the x's, and then the 49. 49's here, that's 7 times 7. Okay, so I put the 7 and the 7 after the plus and after the minus. So we have 6x plus 7 times 6x minus 7. If you rainbow these out, then you'll add the 2x, the x to first will be deleted. That's what we have. Okay, my next problem. Remember what we think of. Do you have x to the second? Yes, so x, okay. Now is this number here a negative? Yes, it is. That's good, so I proceed. If it's plus, you say fail and don't do the problem, but it's going to be negative on all the problems here. Now go look up your 25, okay? 25's here, that's 5 times 5. So I'll put 5 times 5. And 4. 4's here, that's 2 times 2. So that's 2 times 2. So 2, 2. So this is 5x plus 2 times 5x minus 2. Okay, 4x to the second power minus 9. Okay, so we're looking for a plus and a minus of the same thing, okay? All right, so do I have x to the power of 2? Yes, I do. Is this number negative? Right there, negative. Okay, now are both my numbers perfect squares? Well, 4's on this list. That's 2 times 2, okay? So I put 2 in front of the x's as coefficients. And then 9. 9's here, that's 3 times 3. So I put 3, 3 after the plus and minuses. 2x times 3 times 2x minus 3. It's known as the DOPS method, the difference of perfect squares. Difference means we'll have a minus sign, so that second sign's negative. And then are these perfect squares? Yep, x. Perfect squares are products you can write as a factor times itself. Okay, next problem. 25x to the power of 2 minus 16. The sign there is multiplication. Okay, do we have, is our x to the power of 2? Yep. It's like you're splitting that in half. Okay, is the second number negative? Has to be, okay? It is. Now go look these numbers, see if they're on the list. So 25's on here, that's 5 times 5. So I put 5 in front of each of my x's. 16, that's on here, that's 4 times 4. So plus 4 minus 4. Okay, 9x to the second power minus 100. Plus, minus. That's always how you set these up. When you see two terms with the x to the first deleted from the expression, you look to factor this way, using the DOPS method, difference of perfect squares. Okay, so the first thing, x to the second is there, so x. If the x isn't to the second, then you can't do this. You would not do it. Okay, now is our second number negative? It is. Okay, now look up your list. You got 9. 9 is 3 times 3. Okay, now look up 100. 100's down here, that's 10 times 10. Okay, so plus 10 minus 10. So that's is equal to 3x plus 10 times 3x minus 10. Okay, next one. 9x, 81x to the second power minus 4. Okay, so plus, minus. That's how your first thing, put the plus and minus. Every time I'm getting the same thing, okay? If it's if it's factorable, it has to be the same thing with a plus and minus, given the fact that the x to the first power has been deleted. Okay, so x to the second is there, so x. Now check your numbers, 81. 81's on the list, that's 9 times 9. So I put the 9's in front of the x's, because this times this should equal 81. Okay, and then 4's in this bubble, and that's 2 times 2. So we have 9x plus 2 times 9x minus 2. And if you had to solve an equation, these would be your two factors. Okay, remember, if I don't have a number, I would like to have a 1 there. Then if you don't see a multiplying number, it's technically 1. Okay, so do we have our x to the second? We do. X. Now is 1 on the list? Yep, 1. Is 81 on the list? Yup. 9. Okay, and then you have the 4 problems on the assignment, okay? I hope it's been informative, and then we'll continue to work more with this sum in the coming days.